In Greenland, glaciers are very much on the move.
What we're seeing in Greenland is pretty strong trends right now. I mean, the glaciers have sped up over broad areas in the west and the southeast by about 30% over the last decade or so, and that's quite a big speed up. I mean, that's a lot more ice going into the ocean now. It's certainly cause for concern. In Greenland, half the ice melts each year, and half of it breaks off into the ocean and forms icebergs.
The key question: velocity. How fast is glacial ice moving to the sea?
Jakobshavn Isberg, which is this large glacier in Greenland, it's the fastest, biggest producer of icebergs. Since the late 90s, it's way more than doubled its speed. So it's spewing that much more ice in the ocean. Glaciology traditionally has been a very data-limited science.
To gather badly needed data on seasonal velocities, the APL-UW team pioneered and perfected satellite radar interferometry methods, comparing two images from satellite-based synthetic aperture radar to generate maps of surface deformation accurate down to a single centimeter.
What you get is actually an image that looks a lot like a photograph of the ice sheet, except it's coming from radar wavelengths. And by comparing an image from one time period to the next, we can actually observe how much the glacier shifted.
The APL-UW team uses images from several satellites to create a map of most of the Greenland ice sheet, which is then made available to all through the National Snow and Ice Data Center.
The thing about the record is that we're not detecting a trend exactly. We're seeing a lot of kind of spotty behavior in a lot of glaciers in a lot of different places. So it's not like you can just draw a line through the data and eventually decide that that line is significant. What we're seeing is that different areas of the ice sheet are active in different years, and different glaciers have a period of activity and then nothing happens for a while and then there's another period of activity.
It's not a simple extrapolation. If we just could freeze climate where it's like now, maybe we could extrapolate, but really we really can't at this point. So that's where the models come in. The models give you a more informed and more objective way to actually make projections into the future. And they're projections, they're not predictions. You won't be able to say sea level will rise by 40.3 centimeters over the next century, but there is always going to be a range. But the goal is to reduce that range and the uncertainty as well. The big picture is developing models that can predict sea level in 100 or 200 or 300 years from the entire ice sheet. Here at UW right now, we're focusing a little bit more on how the models actually work rather than producing whole ice sheet-wide estimates.
The ice sheet is going to be evolving further in time, and I don't think that there's ever going to be a point at which we'll say we're done collecting velocity data. So I think this is going to be a monitoring effort that could go on for some time.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.